Hello, everyone. Welcome back. My name is Mr. Zebron. So there we go. I'll be taking you through this set of questions which have been sent to me by my students who are currently at home for mid-term break. So we have this question here, which has been sent to me as a picture or a screenshot from a student. So we have this question here. The diagram shows a quadrilateral containing two right angles. Okay, so we have this quadrilateral here, which contains two right angles. Now the question is, can you calculate the value of A? So the value of A, so this is the missing side on this right angle triangles. So what I'm gonna do is that I'm gonna use Pythagoras theorem to find the length of the hypotenuse, which is this side here, which has been showed by using the dotted line. So I'm gonna go ahead, label this hypotenuse as C, and this side is A, and this side is B. Now, from Pythagoras theorem, we know that C square equals to A square plus B square. And this will be equal to, C square will be equal to 7 square plus 6 square. And this will be giving you that C square equals to 49 plus 36, and this will be, C square will be equal to, this will make 15, this will make 85. So C square equals to 85. So if you are looking for C, if you are looking for the value of only C, so you will need to find a square root of that, and this will give you C equals to square root of 85. And if you use a calculator, you're going to end up getting something like 9 point something, okay? Now, because I'm not interested with C, I'm not interested with how much C will be, I'm very much interested with the value of A here. So what I'm going to do, I'm going to stop here on C square equals to 85, and then I'm going to use that into the next step, which is, this hypotenuse has been shared by another right angled triangle, which is this right angled triangle there. So I would still use Pythagoras theorem, which says that C square equals to A square plus 9 square. So I'm gonna go ahead and use the same thing. But what is the value of C square? The value of C square is 85. The value of C square is 85. So I will go ahead substituting 85 here, and this will equal to A square plus 9 square is 81, okay? Now this 81 will be shifted to this side, so it will be 85 minus 81 equals to A square. And this will be 85 minus 81, this will be 4 equals to A square. Now the question is not to look for A square, the question is to find the value of A. So I'll be applying square root on both sides, and then I'll be getting 2 equals to the value of A. If you swap that, you're gonna end up getting A equals to 2 centimeters. You're gonna end up getting A equals to 2 centimeters, okay? So I hope that question is clear and the value of A is 2, all right? So the next question will be this question here. The diagram shows the floor plan of Pierre's room. This is a floor plan of Pierre's room. And Pierre wants to cover the floor with a square tiles. And each tile has a side length of 50 centimeters, which of course you need to change this 50 centimeters into meters. And this will be equal to 0.5 meter. This is 1 meter equals to 100 centimeter. How about 50 centimeter? That will be equal to 0.5 meter, okay? So each tile has the side length of 0.5 meter, and it is in the form of a square, because you know that tiles which are needed to cover the floor should be in the form of a square. So we have this tile, which is in the form of a square, and each side of this square is 0.5 meter, 0.5 meter. So now the question here is, Pierre says that he will need more than 100 tiles to cover the floor, and the floor is in the form of a compound shape. So what I'm gonna do is I will go ahead dividing. So what I'm gonna do is I will go ahead dividing this shape into two rectangles. So like that. And therefore I will have the rectangle A, and then I'm gonna have rectangle B. So let me start finding area A. So I will find area A here. And this area A is clearly a rectangle, which will be length times width. And this will be equal to 4 meters times 3 meters. And this will give you 12 meters squared, okay? And how about area B? Area B is 5 meters wide. And I guess this will be 7 minus 4. And this will be 5 meters wide and 3 meters long, okay? So area B will be equal to, how did I get 3? I just take 7 minus 4, that makes 3. So area B will be equal to 3 times 5. Okay, so this will be 3 meters times 5 meters. And this will clearly give you 15 meters squared. Okay, now to find the area of this floor plan, which is in the form of a compound shape, I'm gonna go ahead adding A and B. So go ahead adding A and B. So area of the floor will be equal to A plus B, and this will give you 12 meters square plus 15 meters square. This will clearly give you 27 meters squared. Okay, now this floor, which has the area of 27 meters square, has to be covered by tiles. Now Pierre says that he will need more than 100 tiles to cover the floor. Okay, so to do that, we're gonna go ahead finding the area of this single tile. So area of a tile, area of one tile, will be equal to 0.5 meter times 0.5 meter, and this will give you 0.25 meters squared. So this is the area of one tile. Now the question here is that if one tile can cover an area of 0.25 meters squared, how about 27 meters squared? The complete floor plan will be covered by how many tiles? So here we're gonna need to cross multiply, meaning that this will be 1 times 27. The answer you get, you're gonna go ahead is dividing by 0.25, okay? So you can help me calculate this using a calculator. 1 times 27 is 27, divided by 0.25. This will give you something like, let me try to check using this calculator here. So we have 27. Yeah, so we have 27 divided by 0.25. Okay, now that clearly shows 108. This will be equal to 108 tiles. So we say that Pierre is correct, because Pierre says that he will need more than 100 tiles, and it's true that Pierre needs somewhere around 108 tiles, which is more than 100. So Pierre is correct. So here we say Pierre is correct. All right. So Pierre is correct because we got 108 tiles, which is something more than 100 tiles. All right. Then that will take us to the next question. The next question is, okay, this picture looks dark, but this is how much my student was capable of capturing, but there's no problem since we can be able to read the writings. So let us proceed. A, B, C, D is a square. Okay, we are given that A, B, C, D is a square. So A, B, C, D, this shape here is a square. So a rectangle is removed from corner C. We have a rectangle here. This rectangle here has been removed. has been removed from the square. Okay. Now the question here is, the side of the square measures 2 meters. The side of a square, meaning this square is measuring 2 meters by 2 meters. Okay, that square. So the rectangle that has been removed measures 30 centimeters by 20 centimeters. So here we need to convert the 30 centimeters by 20 centimeters because the question here demands us to give the answer in meter square. Okay. The question here demands us to give the answer in meter squared. All right. So we're going to go ahead changing 30 centimeters into meters. So you know that 1 meter equals to 100 centimeters. How about 30 centimeters? So this will be equal to 0.3 meter. And 20 centimeters will be equal to 0.2 meters. Okay. So the rectangle that has been removed, this rectangle which has been removed measures by 0.3 meters by 0.2 meters. Okay. So what are you gonna do? The question here says, work out the area of the shape that remains. So what we're gonna do is, first of all, find the area of a square. So here we're gonna go ahead finding the area of a square. So area of a square, will be 2 meters times 2 meters. So will be equal to 2 meters times 2 meters, and this will be equal to 4 meters squared. And go ahead calculating the area of a rectangle that has been removed. So we write here area of a rectangle. A rectangle that has been removed will be equal to 0.3 meters times 0.2 meters. And this will give you 0.3 times 0.2. This will be giving you 3 times 2 is 6. And you have 2 decimal places. We're going to have something like this. Okay. So we're going to have 0.06 meters squared. Let me check properly. 3 times 2 is 6, and we have in total 2 decimal places, and this is how it will be. So the area of the rectangle that has been removed is 0.06 meters squared. Now, can you calculate the area of the shape that remains? So I'm gonna take the area of a square, which is 4 meters square, minus the area of the rectangle, which is 0.06 meters squared. So I'm gonna go ahead taking 4 meters squared minus 0.06 meters squared. And if you do this, you're gonna end up getting 4.00 minus 0.06. The answer will be, this is 9, and this will be 3.94. It's 10, 31. So the answer will be 3.94 meters squared. So that's the area of the shape that remains. Okay, that's the area of the shape that will remain, right? So far, so good. Let us continue. Yeah, let us continue. We have the next question here. Oh my God, this question looks pretty dark, but I'll try my level best to read it. And maybe in the future, students try to take a picture which is not that much dark. Try your level best, okay? If you can't manage, then just send it the way how you captured it. Then I'm gonna try to figure out things. Okay, so we have this question here. I'm gonna try reading it. Jamila has a rectangular piece of garden measuring 1 meter by 1.5 meters. So we have something like a rectangle here. We're gonna try sketching that. So Jamila has a rectangular piece of garden measuring 1 meter by 1.5 meters. So we have 1 meter, 1.5 meters by 1 meters. Okay, now what is the question? She wants to cover it with square slabs that are 0.5 meters along each side. Oh, okay. So she wants to cover this rectangular piece with slabs which are in the form of a square. So we have slabs here. These are slabs. These slabs are in the form of a square which measures 0.5 meter along each side. So we have 0.5 meter by 0.5 meters, okay? Now, one slab costs $2.35. Now, the question here is, work out the total cost of the slabs for this piece of garden. So what I'm gonna do is first find the area. I'm gonna go ahead finding the area of this rectangular garden. So area of this garden will be equal to 1.5 meters times 1.0 meter. Of course, this remains the same, 1.5 meter square. So this is the area of a garden. So this is the area of the garden. Now, I'm gonna go ahead finding the area of one slab. So area of one slab here, area of one slab will equal 0.5 times 0.5. Why? Because that is a slab is in the form of a square. So I'm gonna go ahead writing 0.5 meters times 0.5 meters. And this becomes, if I do multiplication, this becomes 25. We have two decimal places, so we're gonna have 0.25 meters squared. So this is the area of one slab. So if we have to cover this garden by using slabs, but the area of one slab equals to 0.25 meters squared. So we're gonna need to find the total slabs which will be needed to cover the whole garden. So we know that one slab can cover only 0.25 meters squared. So how about the entire area of the garden, which is 1.5 meters squared? So how about the entire area, 1.5 meters squared, will be covered by how many slabs, okay? So cross multiply, this will give you 1 times 1.5. The answer you get, you're gonna need to divide by 0.25 so that you can know how many slabs will be there. So this will be 1 times 1.5, this will be 1.5 divided by 0.25. Okay, you can help me calculate that 1.5 divided by 0.25 using your calculator, but let me try to use this standard calculator. This is 1.5 divided by 0.25. Okay, so I'm getting 108. Oh, let me try to clear that. Okay, right, so let me start afresh. I have cleared all the memories and all the histories, okay? So there we go. So we have 1.5 divided by 0.25. So 1.5, oh, what is happening with me? Let me try again. 1.5, okay, divide by 0.25 equals to, yes, 1.5 divided by 0.25, the answer is 6. So the answer here is 6, meaning total number of slabs, we have 6 slabs. Okay, so the whole garden will be covered by 6 slabs. But then the question is, work out the total cost of the slabs. But we know that one slab is costing $2.35. So one slab costs $2.35. Okay, so we have, let me try to confirm this cost. Yeah, one slab costs $2.35. Okay, so if one slab costs $2.35, how about 6 slabs? Okay, how will be the cost for 6 slabs? So question mark. So here, if you cross multiply, you're gonna end up getting 6 times 2.35 divided by 1. Okay, so 6 times 2.5. So we have this 6, we're gonna multiply by 2.35 equals, so we have 6 times 2.35. 6 times 2.35, we're gonna have 14.10. Okay, so we have $14.10. So this will be the total cost, meaning that the total cost will be $14.10. $14.10. Okay, that is what it means. Anyway, you can try to use your calculators because I'm using these calculators and it's giving me hard time because I'm not used to this calculator. So now, so history, let me delete all the history. There we go. Okay. So now you can use your own calculator and then come back to me if this calculator is giving me hard time because I'm not used to it. Right, there we go. We have another question here. This question is, this question looks a bit complicated. So we're gonna try to read it carefully. A rectangle has width. We have this rectangle here, which has the width of 6 centimeters and the area 60 centimeters. We know that the area of any rectangle is length times width. So if the area is 60 and the width is 6, so the length is missing. So go ahead finding the length. That 6 equals to 6L over 6 over 6. You're gonna end up getting that L is 10 centimeters. So from here to here, meaning that from here to here will be equal to 10 centimeters. Okay. Now a rectangle has width 6 centimeters and area of that much. It is cut into triangle A. It is cut this way into two. Into two shapes, into two other shapes. One shape is a triangle, which is this shape here. Okay, and then another shape, this shape A, which is a triangle. Another shape is a trapezium. Another shape is a trapezium. I think you can clearly see that. Okay. Now, what is the question? The question says that the ratio of the area A to the area B is 1:4. Work out the length X. Okay. Now, if from here to here is X, then the other side, this side here, will be equal to 10 minus X because the whole thing here is 10. So if this part is X, the other part, the other remaining part will be equal to 10 minus X. Now let me find the area A. Let me find the area A. Area A is clearly a right angle triangle. So area A, so let us find area A here. Area A is equal to a half times height times base. And area A will be equal to 1/2 times. What is the height? The height to me looks to be 6. Okay, this is 6 and that will be 6. But the base will equal X. The base will be equal to X. Okay, so area A will be equal to 1/2 times 6 times base is X. So simplify this. This will give you 3 times X, and this will be 3X. So area A is equal to 3X. How about area B? Area B is clearly a trapezium, and area of a trapezium equals 2. So here we're going to write here area B equals to the area of a trapezium, which is a half times height times A plus B. Okay. Now, what is A plus B and what is H? Let us go back to the diagram. The height of a trapezium, you see that the height will be 6, and the A and B's, the A and B, this, the whole thing here, 10 minus X, this is your A, and B will be equal to 10, and the H will be equal to 6 for trapezium. So the A will be 10 minus X, and the B will be equal to 10. How high the trapezium will be, that will be equal to 6, okay? So then I'm gonna go ahead finding the area B. Half times height is 6 times A plus B, as you all remember that A is 10 minus X and the B is 10. So I'm gonna go ahead writing here, A is 10 minus X and the B is 10. Okay, check again. A is 10 minus x and B is 10. So I'm going to go ahead writing 10 minus x plus 10. And if you simplify this, you end up getting 3 times inside the brackets, collecting like terms. 10 plus 10 is 20, then in minus x. So you're going to go ahead getting something like 3, 20 minus x. And if you want to open brackets, we're going to have 3 times 20. This is 60 minus 3x. Okay. So this is area B. Area B equals to 60 minus 3x. Okay. Now, what is the use of this ratio? The ratio of the area A to area B is 1:4. Mind you that area A is 3x and area B is 60 minus 3x. Okay. Right. Now, what I'm going to do is go ahead using the ratio that area A ratio area B equals to 1:4. Let me try to confirm that ratio. Here it says that the ratio of the area A to the area B is 1:4. Okay. So we have 1:4 equals to A ratio B equals to 1:4. Now, what is the area A? Area A is 3x. Area A 3x ratio. What is area B? Area B is 60 minus 3x. This will be equal to 1:4. Okay. So if you write these ratios, as a fraction, from that fraction is where you'll be able to find the value of x. So this will be 3x over 60 minus 3x. This will be equal to 1/4. Now from here, you need to set up an equation by crossing multiplication. So when you cross multiply, you're going to end up getting 3x times 4, 3x times 4, that will be equal to 1. That will be equal to 1 times 60 minus 3x. Now, what is 3x times 4? This is 12x. And when you open brackets here, 1 times any number, it remains the same number. So 1 times 60, that will be 60 minus 1 times 3x, this will be minus 3x. So when you collect like terms, you end up getting that 12x plus 3x, this equals 60. Now to work out the value of x, this will be giving you 15x equals to 60. And to find the value of x, we need to divide by 15. You end up getting that x equals to 4. So that the value of x there will be equal to 4. And that marks the end of this question. So the value of x here will be equal to 4 centimeters. And you get your 3 marks there. Okay, I hope that is clear. Let me move to the next question. Yes, we have this question here. Look at the diagram, which is drawn on a 1 centimeter square grid. Okay, so we have, this diagram looks to be a bit dark, but I'm going to try answering it. So look at the diagram, which is drawn on a 1 centimeter square grid. Okay, so this is the diagram. Now the points A is here, is 2,4. Let me try to confirm. Yes, 2,4. And B is here, 4,4. Yes, 4,4. And C is somewhere here. With coordinates 4,2. Okay, so these points are marked. They are marked here, is how I was trying to show you. Now the question is, can you draw the reflection of the triangle ABC in the line x equal to 5? Now let me try to label where x equal to 5 is. Okay, so I'm gonna try to draw that x equal to 5 in dotted lines. So x equal to 5, this is the x equal to 5. And I'm gonna go ahead labeling this, x equals to 5. And this is what we call the mirror line. This is what we call the mirror line, okay? So draw the reflection of the triangle ABC in the line x equal to 5. Label your triangle R. Okay, label the new triangle as R. Okay, so let me try to reflect one point after the other. Let me start with point B. Now this point B is one box away from the mirror line. So this point B will be somewhere here. Okay, and this will never be B again. Instead, it will be B dash. Okay, and how about this point C? This point is again one box away from the mirror. It will be the same one box behind the mirror. So this will be not C, this will be C dash. How about A? A is how many boxes from the mirror? 1, 2, 3. So it will be the same 3 boxes away from the mirror, I mean behind the mirror. So we have 1, 2, 3. So this will be not A, that will be A dash. And when you connect this, when you connect B dash to A dash, then to C dash, then you'll be getting this shape here, which we call it image. And this image is what we are supposed to label your image as triangle R. So this is what we're gonna go ahead labeling as R. And that marks the end of that question. Then there's this question here, Roman 1. The point D is at 1,1. Point D is at the point, is at the coordinates 1,1. Okay, and then the question is, can you underline the correct name for the shape ABCD? Let us try to connect A to B, connect A to B, then B to C, C to D, and then a D to A. What shape is that? Okay, so you can clearly see that that shape is a kite. Okay, so underline the correct name. So that shape is a kite. Okay, so ABCD is a kite. ABCD is looking to be a kite, not a diamond, not a parallelogram, not a square, not a trapezium. So rather, is a kite. Now, can you work out the area of the shape ABCD? Can you work out the area of the shape ABCD? We are supposed to work out the shape of this area here, which we referred to as a kite. Okay, so we're gonna try finding the area of this shape, which is a kite. Now you can clearly see that this kite is made up of 2 triangles. Okay, this kite is made up of 2 triangles. But remember, this diagram you see is drawn on a 1 centimeter square grid, meaning from here to here is 1 centimeter, and from here to here will be 1 centimeter. And this is what it means by 1 centimeter square grid. So each side of a box here is 1 centimeter by 1 centimeter. Okay, now how do we find the area of this kite here? The area of this kite, we're gonna try to understand that this kite is made up of 2 triangles. Okay, so I'm gonna try to highlight them. The first triangle is this triangle here, which is 2 boxes, which is 2 boxes by 1 box, which is 2 boxes by 1 box, meaning the base is 2 and the height is 1. So the first triangle So area of the first triangle will be equal to area of the first triangle. So we can say area of triangle 1 will be equal to a half times the base. The base, you can clearly see that the base is 2, and why 2? Because you have 2 boxes from here to here is 2 boxes. Okay, maybe let me try to erase this. Then I'll try to count clearly. The triangle which I'm talking about is the triangle which I'm talking about is this triangle here. This triangle here, and this triangle is 2 boxes, and 2 boxes is the base, and the height is 1 box. Okay, so this will be equal to a half times 2 times 1, and this will be equal to 1 centimeter square. So that is area of the first triangle. Now, area of the second triangle, area of the second triangle will be equal to area of the second triangle. You can see that the triangle which I'm talking about is this triangle whose base is 2 boxes by 1, 2. Okay, let me try to remove this so that we can count the boxes clear. Okay, the triangle which I'm talking about is this triangle here, which is having 2 boxes as the height. So the height is 2 boxes, and the base will be remaining the same, 2 boxes. Okay, so the height will be 1/2 times the height is 2, and the base is also 2. So when you simplify this, you're going to end up getting 2 centimeters squared. So the area, the total area here will be equal to the area of this triangle plus the area of the other triangle. So you're going to have total area will be 1 centimeter square plus 2 centimeters square, and the area will be equal to 3 centimeters square. So you're going to get something like that. All right, so so far so good. So we got the area of the shape ABCD. So the area of this shape ABCD, which is this kite, that area will be equal to 3 centimeters square. All right. Let me see if I can proceed with the next question. If I stop here. Okay, so we have this question here. Really draws the graph of y equal to 2x. So really draws the graph of y equal to 2x. Write down the coordinates of 2 points that will be on this line. Basically, what you are supposed to know is that when you want to draw the graph of any equation, you need to have something we call a table of values. Okay, if you want to draw the graph of any equation, you need first to prepare what we call table of values. We need to prepare what we call table of values. Now, how do we prepare this table of values? We just assume the values of x and y randomly. Just assume the values of x and y randomly. And since they need 2 points, so I'm going to assume the 2 values of x. So I can assume, say, x is 1. I just choose any value of x. And here I'm assuming x is 1. Then I will need to calculate the value of y. And also, I will also assume that x is, say, another value, say 2. And basically, we assume just small numbers. And then for the value of y, we don't need to assume again. We need now to use the equation. We need to use the equation to calculate the values of y. Now, what is this equation I'm talking about? The equation I'm talking about is y equals to 2x. So we're going to substitute. We're going to substitute the value of x as 1. We're going to substitute the value of x as 1. 2 times x. X is 1. So this will be equal to 2 times 1. This makes 2. And when x is 1, y is 2. Okay? And what will be the coordinates? The coordinates will be equal to 1, 2. Okay, the coordinates will be 1, 2. And how about the second value of x? So for the second value of x, we have y We have y equals to 2x, and this will be equal to y equals to 2 times, but this time the value of x is 2. This time the value of x is 2. So we're going to go ahead substituting here. This will be 2 times 2, and therefore y will be equal to 4. Y will be equal to 4. And the coordinates will be equal to 2, 4, right? 2, 4. You see? Now, this question, write down the coordinates of 2 points that will be on the line. Now, this question has a lot of possibilities of answers that will come here, right? So either way, how you can clearly get the 2 points, and you just, these 2 points usually come from the, what we call the table of values, okay? Right, so let me see if I can push more questions here. Yes, let me end up with this question, because this video I don't want to make it so long. Okay, let us continue with this question. All right, now this question says, here is a square. I don't know if I can zoom this. Try to make, okay. All right, so let us try to do this question here. All right, so here is a square, EFGH. So we have this square here, EFGH. So we have EFGH. This is our square, okay? So here is a square. Now, EFGH is drawn on a grid. Grid means something like a graph paper. So EFGH is drawn on a grid so that E is at 1730. So E is at 1730, meaning that the coordinates of E are 1730. So this is E, and H is 1733. H is 1733. This is H. Okay. Now, what does this mean? What does this mean? E is at the coordinates 1730 and H is at the coordinates 17,33. What does this mean? That means the difference between, or the distance from E, the distance from E to H will be equal to 3 units, meaning you can see that here, the values of X are the same, but the values of Y are different. The values of Y are different. So the distance will depend on the values of Y, which will be equal to 33 minus 30, and this will be equal to 3, meaning from here to here will be equal to 3. Now, since this shape is a square, so from here to here will also be 3. From here to here will also be 3. From here to here will be also 3. Why? Because that is a square. Now, can we get the coordinates of G? Can we get the coordinates of G? Yes, we can. Can we also get the coordinates of F? Yes, we can. How? Here, this is just a horizontal line. This horizontal line, meaning it is going to maintain the value of Y. The value of Y will still remain the same, 33. But the value of X will be changing by adding 3 to it. So when you take 17 plus 3, you'll be getting 20. Okay. So the coordinates of G will be equal to 20,33. How about the coordinates of F? You can try pausing this video and try to figure out what will be the coordinates of F. But let us continue. The coordinates of F will be the same as the value of Y will be the same. The value of Y will be 30. Okay. The value of Y here will be the same 30, but the value of X will be, 17, add 3, this will be 20, this will be 20,30, okay? I hope that is clear. So this we have 30, 20,30. The value of y here will be maintained because you are moving along the horizontal line. Okay. So the coordinates of f will be 20,30. Now draw a ring. The question here is EFGH is then translated 3 right and 4 up. 3 right. Let us try to write what we call translation vector. Translation vector. Now the translation vector will be 3, 4. This is the translation vector. Okay, 3, 4. Now, how do we use the translation vector? For example, if you want to find the coordinates of H, if you want to find the coordinates of the image H, so what do? We have H with coordinates 17,33, 17,33. Now, if this is going a translation of 3 right and 4 up, meaning that we're gonna get a new point, which we call it H dash. And what will be the coordinates of this H dash? We simply add, to get the coordinates of H dash, we simply add what we call the translation vector, which is 3, 4. Add 3, 4. Now, when you add this, you're gonna get 17 plus 3, this will be 20, and 33 plus 4. Add this, 33 plus 4, you're gonna end up getting 37. Now, do we have 20,37? We have 20,37. 20,37. No, we don't have. Possibly, we're gonna move to another coordinates, which is E. Now, with coordinates of E, we have E is this one here, 17,30. 17,30. Now, to find the image of E, this will give you E dash. And how do we use the translation vector? We're gonna add the translation vector to this. Okay, we're gonna add 3, 4. All right, and when you do that, you're gonna end up getting something like this. Let me try to push this a bit down. Okay, so when you add 17, add 3, you're gonna have 20, comma. When you add 30 to this 4, you're gonna have 34 here. Now, do we have 20,34? Yes, we have. So draw a ring around the 2 coordinates that are vertices of the square after this translation. So this will be one of the images, 20,34. So we have to keep going until we finish. We have to keep going until we finish the remaining other 2 vertices. Okay. So we have done E, we have done H. We are left with G, which is this point, and finally F to this point. Let's go to G. Okay, G is 20,33. G is 20,33. Let me confirm this. G is 20,33. Now, to find the image after this translation, to find the image of G, this will be giving you G dash. Now, to these coordinates, we have to add what we call a translation vector, which was a translation vector was 3, 4. So 3, 4, add this. So how do we add? Take 20 plus 3. That will give you 23. And 30 plus 4, that will be giving you 37. Okay, 37. Now, do we have 23? Do we have 23, do we have 23,37? Do we have 23? Yes, we do. This is also another coordinates of the vertices after this translation, 23,37. Now let us try to check the last one, which was H. The last one, which was EFGH. No, H was done. What is left here? F. Okay, F is this one here, which is 20,30. 20,30. Now to this 20,30, we're gonna need to add a translation vector so that we get its image. Okay. So when we add a translation vector, which is 3, 4, if we add this becomes 23, comma, and lastly, this becomes 34. 34, okay? So we have 23,34. And do we have 23,34? 23,34. No, we don't. And this marks the end of this question, because they say draw a ring around 2 coordinates. So the first coordinate is here, another coordinate is there. So you draw a ring around that, okay? So I guess for today, let us stop here. We're going to proceed tomorrow. All right. So until next time, bye-bye for now.